Okay, so the first thing I'm gonna have you guys do, if you have a little piece of scrap paper or whatnot, or a pencil, yeah, or you could write on the desk too, that works if you have an expo marker and you wanna do that. This is gonna be a couple quick warm-up questions that we're gonna do. This would relate back to a previous lesson about angles and whatnot that we've done. First question is on the board, and then when you guys all have that, give me a thumbs up, and then I'll move on to the second one, so then we can talk about that one as well. Okay, so how, everyone feeling okay about the first one? Okay, so I'll show you the second one. So does everyone understand what this question is asking? Okay. So is everyone good to go back and go over these now? So let's look at the first question. So is there anyone that wants to explain what they got and talk to the group about it? Or what were your guys' answers?
I got C for the answer.
Okay.
So what I did was I had, since you're multiplying the two numbers together, I added their exponents. So I got 3 to the negative third, and then I just flipped it so it was 1 over 3 to the third, and then I did that out, so it was C.
Alright, so does everyone agree with that idea? Okay, cool. So now let's look at the second one. So who wants to explain the process for this one? Anyone want to volunteer?
Sure, okay. So I found the supplementary angle to angle 1 first. So angle 1 I said was 148, so I found the other side, which was 32. And then using alternate interior angles, that 32 let me know that angle 3 is 32, and then I could use the same idea of supplementary angles to find.
So when you're talking about the angle, are you talking about this? Oh, well, that's cool, but that's not what I wanted. So, I forgot the touchscreen. So are you talking about the gray angle, or are you talking about the white angle over here? So then you have the alternate interior? Is that what you're going on?
Yeah, I was thinking of the gray as like a dividing line instead of like an extra angle, but now I see that.
I see what you're talking about, that's cool. I hadn't looked at it that way. So yeah, I had seen as, I did it again. So the angle in here I said was like 32. And then those go together.
So you're saying there's like two similar angles in that, like...
You guys see what I'm talking about?
Yeah.
Stop. How angle 1 could also go with this gray angle in
Yeah.
there. So I saw it that way. But you could also do it your way, or the white angle and this white angle. So then that one goes, that one is alternate interior. And then that's that angle as well. Okay, so we talked about the congruency of these angles, so you ended up, what was your answer?
Angle 3 is 32, so yeah.
So you had D. Okay, so angle 1 and angle 2 are congruent. So now that we've talked about congruency of angles, we're going to talk about congruency and similarity of figures. So if we were doing transformations to them. So let's move on to that. So there's 4 different types of transformations that we're going to talk about today. So, and then we're going to have hand gestures that go along with them. So the first one is translations. So when you first look at this, the black figure is the one we start out with. And then this blue figure, we call that your prime figure. So any point on it, so N turns into N prime. K here turns into K prime. And I turns into I prime. So whenever we do a transformation to a figure, it turns into the prime figure. So just looking at this one, how does it move on the graph? Just kind of like directional words. You want to explain or?
Left and then.
Okay, so that's how we're going to do hand gestures for this. So translations, it goes like this, or it goes like this. So it either goes up or down, or it goes side to side, left and right. So we call that our sliding line. So now looking at reflections. So this is our original figure. Can I have someone, yeah, can I have someone else explain what they think happens to it?
So like, they get reflected over the y-axis.
Okay, so how, is it kind of flipping?
Yeah.
So that's a gesture we're going to have. So like flipping pancakes kind of thing. So we're going to have your hand go like this. So this is reflect, and then this is, you do that. So that's your translation. No, slide. Doesn't work. Anyways, I'm not a tech person. So, next one. So this is our original figure again, the black one. So can I have Linda explain this one? What do you think happens to it? And then we'll go over the hand gesture with it.
It rotates.
Okay, so how's it? Good, it's rotations. Alright, so how does it look like it's rotating? Do you see like which way it's going? Like if you imagined a clock, is it going to the right or is it going to the left?
The right.
Okay, so.
No. Yeah.
Alright, you okay?
Is
Are
it
you a
right?
little confused? Yeah, so I mean,
Doesn't
I
matter.
see it going this way, but Nick's right, it doesn't matter. Because you can go, we'll talk about this more later on in a couple other lessons, but you go 90 degrees this way, or you can go 270 that way. So if you go 3 times this way, it works. If you go 1 way that way, it works. Yeah?
So what's the point that is rotating about in this case, or is it just 90 degrees?
It would be going about the origin.
Okay.
So, the idea of the clock. So a clock's a circle. So I had a couple different ways we could do this one. So we could either like have rotate, or you could have rotate, like a full circle hand gesture, or you could like rotate like this. Do you guys have a preference?
I like this one
I
better.
like
You like this one? Okay, so we can do that one.
I'll do it.
Alright, so, Jeremy, the last one. So what happens to this prime figure from the original figure?
Smaller.
It gets smaller? Okay, so then we're going to go off the idea of pupils here. So, it's a fun one. So dilation, it's like how Italians do dilation. So you have, it gets smaller or it gets bigger. So then smaller or bigger. You guys okay with that? So can we go over the 4 again? So what's translation? Okay. What about reflection? Okay. And then rotation. And then last one, dilation. So if it gets smaller or if it gets bigger. Cool. Good. Sounds awesome to me. So what we have now is we're going to have a couple figures that we're going to go over. So here on the left, there are these 2. Okay? So can one of you tell me what you think happened with this one, the top left, using the hand gestures? Okay, so you're all agreeing that it's a reflection. So, original figure turned into this one, it reflected across some form of line. So now what about this one? What do you guys think it is? Okay, cool. Alright, good. So we all agree on that. Now what we're going to have is I'm going to have you guys break into pairs, and I just want you to talk about these two figures. Once you guys get those two done, then I have a couple more for you to look at, and then we'll come back together in about 3 minutes or so, and we'll discuss what you guys thought. So if you guys can talk about that, or you can even draw if you want to. Anything.
No. It reflects, so like there's two steps right here. Those are here too. It reflects off this reflection. This is here.
Yeah.
X-axis is right here. It reflects off this one. Because your M is right here. And then
But if you rotate it,
your M prime, it comes up here.
it
So
changes.
it's getting reflected over this one.
This is W.
See how like everything is the same distance away from each other? It's not
It's
wrong.
just like, okay.
And this is now F prime, isn't it?
Yeah. Yeah, the rotation is correct. You just point right. This is the this is
not.
F. That's not like F times over here. Reflection. I'm gonna like move that here over here.
But that one's a rotation.
Same distance away from Michael one.
Oh, so,
Yeah. Rotation.
So are you guys good with the first two? Okay. I'm gonna show you the next 4, and then we'll have a couple minutes, okay? So we have these ones. So this one, this will be our second, third, fourth.
Rotation, this one.
Mm-hmm.
Anyway,
And
it's
then-
180 degrees. And then the third one. Well, I feel like called augmentation. When you augment something just bigger. That way, yeah, that way. Third dilation.
Hey, do you guys want to make it decent, right? It's alright.
I don't think it works on wood like that. You have to do it on like a smart board.
Oh, okay, cool. That's good to know.
Like the little, blue tealy, the pen, the notebook icon, yeah.
This one?
Yeah.
He doesn't have his
You
format on
copy
there.
and paste it.
If you just like move the window so it's smaller, you should be able to like put it on the side.
So, make it smaller.
Yeah.
Touch it with your finger.
Yeah, not the pen. You might have to put the pen back.
Move. Okay. Oh. No,
You might be able to copy and paste it.
nah, it's
Just-
okay. It's not too significant, but
Okay.
it's fine. I was just curious. Anyways, so are you guys all good to go?
Yeah.
Alright, so let's go back and we can discuss these. The idea I wanted to have was have you guys come up and explain, so I'll still have that. But, so with this first one, so can I have someone come up and explain what they did, give the hand gestures to everyone?
I'll do the first one.
Okay.
So, I said it was a reflection,
Mm-hmm.
because it was reflecting over the, y equals 1 line. And the reason I knew that is because it was the same distance away after the reflection. So like F is here, and then F prime is here. And so F is 1 unit away, and then F prime is 1 unit away.
The same thing with M and M prime, and then the same thing with W and W prime.
Oh, nice. I like it. Thanks, Nick. Okay, so we're gonna move into the next one then. Does anyone want to explain what they got for this one? Cool. Thank you, Hattie.
So we decided that it was a rotation
Okay,
and
cool.
that it rotates to the left
Mhm.
most easy.
Okay, so then it's gonna rotate like this.
Mhm.
Cool. Good. And then here, we'll have the last couple. So you guys can just explain what you think happens on this one up here. Does anyone just want to shout it out? Okay, cool.
Rotation.
Rotation, cool. Alright, what about this one? What do you think this is? Alright, dilation. How about this last one? Dilation again. Cool. And then what about this one? Awesome. Cool. So what is this again?
Translation.
Translation. Alright, so it's sliding down. Cool. Alright. So I mean I had a few more things, but I only have a minute, so that's about where I'm gonna call it for this one. So yeah, the whole big idea to remember is that we have 4 different transformations. And then the idea is that there's like a homework assignment where the students would get a review over this and we'd go over which one is actually different from the others. So we've talked about how dilation is different from the other 3. So, thanks guys.
Should we keep that open?
Keep this open?
Yeah, I'll use that.
You can use Google Drive and stuff?
No, you can cloud it.
I think it's okay to get on GeoGebra.
No, I need that.
Oh, that's you?
Yeah, I need that.
Okay. I didn't know this was